T-minus 1 minute and 30 seconds and counting. The launch vehicle, payload, ground systems, and eastern range are go for launch.
T-minus 1 minute 20.
Upper stage LH2 securing started.
T-minus 1 minute 10.
T-minus 1 minute and counting.
Box go.
Rock, report range status.
This is the Rock, range green.
50 seconds. 45.
Launch enabled. GE main power off.
Main power off. Upper stage LH2 secure at flight level.
T-minus 30 seconds.
T-minus 30.
Status check.
Go Delta.
Go WGS.
25.
Green board.
Flight lock-in.
23.
SRM TVC blowdown.
15.
Rofi ignition.
T-minus 10, 9, 8, 7, 6, 5, 4, 3. We have ignition. 2, 1, 0, and liftoff of the United Launch Alliance Delta IV rocket carrying the 7th WGS satellite for the United States Air Force. The Wideband Global Satcom satellite provides significantly increased capacity for our nation's leaders, warfighters, and international partners.
Maximum SRM chamber pressure now. Coming up 30 seconds. 34 seconds, Mach 1, vehicle now going transonic. Passing 40 seconds, altitude 3.7 nautical miles. 45 seconds, maximum dynamic pressure, max Q on the vehicle. 50 seconds in. Altitude 6.38 nautical miles, velocity 2,532 feet per second, downrange distance 4.43 nautical miles. 1 minute into the flight.
You are hearing the voice of Steve Agate providing launch vehicle ascent data.
Miles, velocity 3,646 feet per second, downrange distance 7.44 nautical miles. Standing by for a solid rocket motor burnout, about 10 seconds from now. And we have burnout, standing by for SEP. And we have separation. 4 solid rocket motors have separated. 1 minute, 50 seconds in. Delta vehicle now weighs half of what it weighed at launch, expelling propellant at the rate of 1,945 pounds per second. 2 minutes into the flight. Altitude now passing 35.5 nautical miles. Velocity 6,443 feet per second. Downrange distance 34 nautical miles. 2 minutes, 14 seconds in. Past Mach 5. Hydrogen supply valve on the second stage are open, allowing fuel for our second stage flight. Passing 2 minutes, 31 seconds. Two minutes, 40 seconds in. Altitude 54.7 nautical miles, velocity 8,773 feet per second, downrange distance 67 nautical miles. Bearing separation should be about 15 seconds from now. Standing by. And pairing SEP. Good pairing SEP, 3 minutes, 14 seconds in. 75.5 nautical miles in altitude, 12,000 feet per second, downrange distance 116.8 nautical miles. 3 minutes, 28 seconds in. We'll be going to the partial thrust mode about 15 seconds from now. 57% thrust level, standing by. And we've been commanded to partial thrust. Standing by for main engine cutoff. Main engine cutoff. Standing by for stage sep. And we have stage separation. NEDS is deploying. Standing by for the igniter spark. The igniter spark, standing by for ignition. And we have ignition. Ignition on the second stage. Second stage chamber pressure is coming up. Good chamber pressure on the second stage. Good stable burn. Recovering from the initial ignition transients. 4 minutes, 41 seconds in. Altitude now passing 144 nautical miles.
This is Delta Mission Control at AL plus 4 minutes, 58 seconds. We've just heard Steve Agid report the successful execution of the early events of tonight's flight, and all systems continue to operate nominally. The Delta IV and WGS satellite are traveling southeasterly over the Atlantic Ocean, away from the Florida coast. The mission is now in the first of 2 planned RL-10 engine burns. This burn will last approximately 16 minutes. I'm joined now by Captain Doug Downs of the Air Force's Military Satellite Communications System Directorate. Captain, thanks for joining me.
Thanks, Trevor. It's an honor to be here.
So what does the WGS system provide to the warfighter?
Well, Trevor, the WGS system, which was first launched in 2007, provides the warfighter with worldwide, anytime communications. A single WGS satellite has more communications capability than the entire Discus constellation. On top of that, it also provides the ability for crossbanding, which means you can connect the X-band and Ka band for users that might be on those different bands at any time. This provides the unique ability to support the warfighter whether they're at tactical headquarters or on the move. WGS currently collects and routes real-time data through thousands of fielded terminals worldwide, supporting tactical communications. WGS satellites also support the Global Broadcast System, also known as GBS. You can think of this as being like DirecTV. It's always there, always broadcasting. You just have to tune in. Warfighters can do that to get some situational awareness. In addition to providing the essential communications for the command and control of deployed forces, WGS also provides the warfighter with a 24/7 means of communication, allowing for coordination of efforts or calling for support if required.
Okay, so for users that may not have a real good understanding of satellite communications, can you explain a little bit more about how that works?
I'd be happy to, Trevor. So it starts off with some information that needs to get from one point to another. For example, let's say a combatant commander in Afghanistan needs to get some support from Allied forces on an aircraft carrier in the Indian Ocean. So in the past, the way you had to do this, way back, you started with signal fires, smoke, flags, things like that. And you moved on to wires and eventually terrestrial radio. But all of these methods have some drawback. Either speed, it takes a long time to get that message over, or you have line of sight issues. If you don't have a direct link, a mountain's in the way, won't be able to make that communication. So to solve this problem, you can put a satellite above the Earth at about 22,200 miles. So at this distance, you see about a third of the Earth's surface. From that position, your satellite, in this case WGS, can send and receive communications almost instantaneously, 24/7. And in our case, the battalion commander would be able to use an antenna within that field of view of the satellite, that 1/3 of the Earth's surface, send the communication to the satellite, they'll collect it, route it, send it back down to the Allied forces on the aircraft carrier. It doesn't matter how far apart they are or what is in the way, that communication will get through.
Wow, fantastic. That's some impressive stuff. Can you tell us a little bit about the WGS-7 satellite itself?
Well, the WGS-7 satellite is rather impressive itself. So on orbit, when it's in its final position, it'll weigh around 7,600 pounds. So to put that in perspective, you're talking about the weight of a 3/4 ton pickup truck. And then once the solar arrays are fully deployed, so from tip to tip of those arrays, you're looking at 135 feet, which is even more than the aircraft that you might have flown into the Cape with, which is probably a Boeing 737 or something similar. WGS-7 will orbit the Earth in a geostationary orbit, which means the amount of time it takes for the satellite to orbit the Earth is the same amount of time it takes the Earth to revolve once about its axis, so about 24 hours. This unique orbit allows the satellite to stay directly over a given point on the equator, so you don't have to try to be adjusting to maintain communication. To make this happen, you have to have the satellite at about 22,200 miles above the Earth's surface and be traveling around 6,800 miles per hour, which is smoking. You're moving fast at that point. And over the 14-year design life of a WGS, you're going to travel 900 million miles. Wow. With WGS seeing nearly a third of the Earth's surface and providing critical communications ability, it's an absolutely necessary asset.
Absolutely. So what role does the WGS program play in the Air Force's overall mission?
Well, military satellite communications, or MIL-SATCOM, provides a critical capability to our troops, our nation's leaders, and our allies. So the WGS program provides a piece of that. They provide the wideband portion of the communication as part of the MIL-SATCOM Directorate. The mission at the MIL-SATCOM Directorate is to acquire and maintain these communications capabilities with ever-increasing capacity and acquisition efficiency. Many military satellite communication programs are developed, managed, and sustained by the MIL-SATCOM Systems Directorate.
Okay. How does this mission fit into the Space and Missile Systems Center?
Well, the Space and Missile Systems Center, or SMC, is responsible for fulfilling all sorts of DoD, Department of Defense, space-related needs, to include the acquisition of space launch vehicles like the Delta IV that had carried WGS now into orbit, as well as providing for the navigation, weather, and missile warning satellites. On top of that, they do the ground systems that support those satellites, like the Air Force Satellite Control Network and the Command and Control System Consolidated, which will actually provide the command and control for the platform of the WGS satellite once it's on orbit.
Captain, what's your role with respect to WGS?
Well, Trevor, I'm one of the lucky few engineers who gets to work directly with Boeing to ensure that the requirements and mission of the WGS satellite are met over its entire 14-year design life. Along with that, I also get to work the ground side, ensuring that requirements are met, any issues are taken care of, and the interfaces are properly coordinated. I'm also directly involved in the new wideband digital channelizer upgrade that will be flown on WGS-8. This upgrade is rather impressive in its ability to provide an increase of 40% to the communications capability of the satellite. Overall, I'm part of the exceptional MIL-SATCOM, an SMC team that ensures 24/7 worldwide communications to our military and international partners.
Excellent. Well, Captain Downs, it sounds like you have a fascinating job. If you don't mind, can you stay with me for a little bit longer? I might have some more questions for you.
I certainly will.
This is Delta Mission Control at T plus 12 minutes, 24 seconds. We're approaching the end of the first of two planned RL-10 second stage engine burns. The Delta IV and WGS satellite are flying over the Atlantic Ocean off the west coast of Africa. Our next event, the first main engine cutoff, or MECO-1, is scheduled to take place just about 7 minutes from now. While we wait for the next mission event, let's take a look at a video highlighting the important capabilities of the WGS system.
Bulldog, Benji, do you copy?
I copy, Mark.
15-second AB takeoff. Please contact Center 1502627,000.
5 Sierra, 4 kilo.
One very round out.
Tiger 22,
And liftoff of the Atlas V rocket carrying the WGS SV-1 spacecraft, WGS-2,
WGS-3.
WGS-4,
WGS-5, WGS-6 satellite for the United States Air Force.
WGS today provides critical and vital wideband communications capability to the warfighter and international partners.
It's a global reach system so that no matter where you are, what time of day, WGS can reach you.
And with the wideband communications, we're able to direct forces all over the world. This can mean the difference between life and death, between mission success and failure.
We're talking about the sailors, soldiers, marine, and airmen in the Middle East or anywhere that is needed.
Being able to communicate over the same system allows joint, seamless operations anywhere on the globe, whether it be for humanitarian efforts or in the presence of a hostile environment.
One can imagine a very adverse situation where our servicemen need immediate communications. It's always there for them. It's like a beacon in the sky.
The Air Force has partnered with allied nations to provide a cost sharing on the WGS system. In turn, these nations have access to the WGS fleet.
They take advantage of the on-orbit infrastructure and are able to get preemptible bandwidth across the entire constellation.
We benefit from it, they benefit from it. This helps build our coalition.
What WGS represents to Australia is our ability to operate with our allies across the globe, and I can assure you that while the world is uncertain, the Australia-US alliance is an absolute certainty, and WGS represents that.
Vehicle over vehicle, block over block, the satellite has been able to evolve and provide significantly increasing capability while driving down the recurring cost of each vehicle.
WGS is unique in that it features an advanced phased array antenna. This antenna is capable of reshaping the coverage pattern at any point.
And put communication where it needs to be.
We also have cross-banding capabilities, so we can go up in one band and down in another.
What it does is receive the X-band capability, and then through the satellite, it converted to Ka band.
So no longer are soldiers, warfighters, or humanitarian aid personnel limited by the type of ground terminals they have.
In our Block 2 satellites, which is 4 through 6, we introduced RF bypass,
which allows UAVs capability to broadcast high-definition video over our Ka band antennas.
Making sure WGS can operate without being subject to malicious activity is one of the key concerns of the WGS program.
So in cases of jamming, our antennas are reconfigurable to eliminate the effects of any unintended interference from a jammer.
This removes the adversary from the line of sight and restores normal communications to the system.
It has the ability to continue to evolve to meet the needs of the warfighter into the future.
One of WGS's core missions is to support humanitarian efforts.
Recently, WGS was critical in making connections between X-band and Ka band for tsunami relief in Japan.
The Japanese emergency equipment operate on the Ka band, and WGS was able to provide that Ka capability.
There's an incredible amount of pride working on the WGS system, knowing it saves lives and keeps people out of harm's way.
Whether it's important military operations or just allowing someone who's deployed to speak to their friends and family back home. It's a good feeling, and I think we're doing a good mission here.
Continues to look good. Good engine control on the second stage. Altitude now 149.2 nautical miles. Velocity increasing to 26,097 feet per second. Downrange distance 2,538 nautical miles.
This is Delta Mission Control at T plus 17 minutes 59 seconds and counting. The Delta IV rocket carrying the WGS-7 satellite lifted off from Space Launch Complex 37 at 8:07 p.m. Eastern Daylight Time. We're about 2 minutes away from completion of the first of 2 planned RL-10 engine burns. Let's join Steve Agid for mission progress.
Seconds. Altitude 137.2 nautical miles. Velocity increasing to 26,908 feet per second. Downrange distance 2,683 nautical miles. 18 minutes, 30 seconds in. 1 minute, 25 seconds remaining in the burn. Chamber pressure continues to look good, and engine control continues to look good. "18 minutes, 45 seconds in, 1 minute, 10 seconds remaining until cutoff of the second stage. Coming up on 19 minutes. Mark, 19 minutes into the flight, about 55 seconds remaining in the burn. Chamber pressure continues to hold. Good engine control. Okay, 19 minutes, 30 seconds in. We'll be standing by for the second stage engine cutoff about 20 seconds from now. "19 minutes, 42 seconds in. Standing by for shutdown. And we have cutoff. Second stage engine has shut down. Now 20 minutes, 15 seconds into the flight. The second burn of the second stage take place approximately 9 minutes and 20 seconds from now. About 19 minutes, 57 seconds correction.